open your video, please? In the event you cannot hear, please tell me. Kalau you tak dapat dengar, tolong bagi tahu I.
Okay, sir.
Alright, thank you. So our two. As the name suggests, is basically linking data. Alright. So basically, you imagine a train, and each module in the train or the grabber, okay, or the coach, that one is the data linked together by the rantai between the trains. Okay. Okay. So what is our learning objective today? We're going to review class of struct and pointer data types. We're going to look about linked lists. What are the different types of linked lists? Singular linked list, doubly linked list, circular linked list. And then we're going to look at what is a property of a linked list. How do you design a linked list? What are the reserved words that you use to create a linked list inside the dynamic memory? Okay. Then basically, when you have the linked list, right, how you add data inside the linked list. So this linked list is very heavily reliant on pointer. Okay. How would you design it? It's basically you imagine you are like I would say like a electrician, like wiring, that's how linked list works, right? Because you are linking one wire from to another module, like linking a bulb to another bulb. All right. So we're going to look how you insert data inside a linked list, how you search within a linked list, how you traverse. Traverse is like when you go inside an array, like you look at index 1, 2, 3. A linked list also you can do that, right? But how would you traverse? You're going to use a pointer. Okay. Okay, then traversing all inside this one, how to build and manipulate linked lists. And then we're going to look at superficially, we're going to look at how to construct a doubly linked list. But what is covered inside the lecture, okay, can be applied to the doubly linked list. But inside the doubling linked list, it is not the implementation detail inside this lecture is not in depth sangat. Okay, because we are looking at the theoretical, we're looking at the basic concepts, right? So for further information for doubly linked list and for circular linked list, you have to refer your textbook, because we cannot cover all of them in one lecture. And then we're going to look at STL container list. And then we're going to look at what is header and trailer. So header and trailer, basically remember in this list, you're going to learn two types of pointer you're going to use, head and tail. Alright, head and tail. But tail sometimes they're called trailer, or we call rear linked list. It's all the same actually. The concept is front and back basically. Some people even use the concept of front and back instead of head and tail. But they mean the same thing. Okay, so then don't get confused with that, just the name. And then be aware of a circular linked list. So this is what you have learned last time, struct. Alright, struct name, reserved word is a structure. A structure can contain different data types. Alright, ends with a semicolon. So this is two structured. One is structured variable, the other one is a pointer. To access the data member, you use the dot operator. Right? The dot operator has higher precedence than the star operator. So this basically assigns 3.2 into the GPA member of student type for the structure variable student. Okay? Using student pointer. Okay? Now, another way is you use the arrow here. Alright, so you just use this arrow here, GPA. So student pointer access the GPA and give it a value of 3.2. Alright, so this is what you have already covered in last semester, a structure. Alright, now linked list is a type of data structure. Okay, it is basically a collection of nodes that is linked together. How would you link them? You're going to use this fellow here at the end there. So every node, ni satu node ni, dia mesti ada pair, data and link, data and link. Link is the benang or the thread that you use to link one node to another node. So you imagine this one node, one data. This link is the one that connects them, the wire that connects them. Okay? So what are the components of a node, Rebecca?
The data and the link.
The data and the
Link.
yes, correct. Ingat tu, itu konsep asas linked list. You are dalam property dia ada data, ada link. You must know this one. Okay, kalau you tak faham konsep asas ni, then you don't understand much. Okay, so ingat tu ya. Konsep asas linked list, dia akan ada satu node. Inside the node, dia ada data and dia ada link. That is the fundamental. Alright. So the data is the relevant information lah. So the data could be a number, it could be a float, whatever lah. Data is data lah. And the link is the one that points to the next node. Alright. So you end up with a train like this. Don't look at the head and tail first, forget about that one. Look at this one. This is one node. This is one node. This is one node. This is one node. Alright, inside there got all the data. Linked together by the link. Okay. Now we're going to put in the concept of head and tail. Head must always point to the first node inside the linked list. So the value of the head here is the address of the first node here. Okay. The tail points to null, points to nothing. Okay. So this holds the data for this new node. This guy here got data and then got link. What is address of this? What is the value of the data of this link? Now, the link is a pointer to the next node. What does a pointer hold? A pointer holds an address, correct? Therefore, 45 here, the link here, what does it hold? What data does it hold?
Address.
Betul. Address of what? Specific sikit boleh?
65.
Correct. Betul. Very good. Understand? Okay. Ini konsep asal. Siapa tak faham, tolong tanya sekarang. Supaya saya boleh repeat. Because selepas ni, lagi banyak kita akan belajar. So, lagi detail. So, you must understand the concept. Daniel, okay, Daniel? Alright, good. Awesome, sure? Ada? Alright. Okay, ini adalah different types of linked list. Yang kita tengok tadi adalah singly linked list. Ataupun singular linked list lah. Singly pun okey lah nama dia. Basically single. Now, ini circular linked list. Circular linked list berbeza dengan single linked list dengan basically how it's different is that the head or the first, doesn't matter, the same thing, points to the last node. Why it points to the last node? Kenapa you letak dekat last node? Simple. When you point dekat last node, ia memberi you advantage of saying first points to the last node inside the linked list, and it also allows you to specify first link points to the first node inside the link. First ni, nama dia first. Nama dia pointer dia first. Dia point to the last node inside the linked list. Dan dia juga allow you to tell you that the last node here, first link, dia punya link ni, points to the first node inside the linked list. That's why you have this connection here, therefore it is circular. Kalau you point first ni dekat sini, then dia tak circular lah. First ni point dekat second ni. Betul tak? Right, so ini first link point kepada first node. So dia dapat create the circular loop. Okay, any question? Ini doubly linked list. Doubly linked list ni, node dia different. Node dia ada dua pointer. Satu pointer basically satu pointer to the next node, satu lagi pointer points to the previous node. Dia tetap ada first and last. Sama macam singly linked list. Just that dia ada extra pointer. Okay, any questions? Alright, so when do you use the list? Alright, you use it when the collection is linear and consists of same data items. Semua data kat dalam tu kena sama. Alright, and then it does not depend on the time of insertion. What does it mean times of insertion? Contohnya time of insertion macam you pergi bank. You pergi bank, orang yang masuk dulu kena keluar dulu, betul tak? Okay, first in, first out. You masuk, you queue kan? Alright, so you kena layan you dulu. Alright, so ini untuk list, dia tak boleh keadaan yang macam first in, first out ataupun last in, first out. Tak boleh. Dia does not depend on timing of the insertion. Alright, and it's also for insertion and deletion, insertion and deletion that occurs frequently. And then you put in data banyak kali lah. Put in data and remove data. Okay, now we're going to look at circular linked list. Okay, so this is how you create it. Struct, okay, node type, data, pointer. Alright, so ni you basically declare head pointer, point to the first node. Ni node type head. So ni basically declare pointer head. Now, this is basically all the different types of nodes, not different types of nodes, same type of nodes, different address lah. First node addressnya 2000, second 2800, third 1500, dan the last one is 3600. The first pointer holds the address of the first node. So the first node is 2000. So it holds 2000. Alright. Now link here. Why does it hold the value of 2800? Vincent Chu.
The address of the next node.
Because okay, address betul, dia also nak wujudkan the linkages between this node and this other node. Faham tak? You want to create the train basically. You ingat macam tu. Link list tu macam train kan? To create the train, the link, you must create this guy here. Okay? So, bila orang type head, okay, arrow, info, head, arrow, info, gives you the value 17. Head, link, will give you the value 2800. Head, link, head, link, info will give you the value of 92. Senang tak? And this one easy lah. Now, okay, ini kita copy pointer. Basically kita cakap, okay, I am going to create a new pointer called current. And then I'm going to say current is assigned to the value of head. Basically, it means current is pointing to whatever head is pointing to. Head pointing to here, betul? So, current is pointing to here as well. Because the value is assigned. The value of head is assigned to current. So, 2000 assigned to current. So that the current value has the 2000. Why is the current for the value 2000? Because it's a pointer. Okay. Banyak sikit ada digest slowly. Okay, ada soalan? Tak ada Okay. Now, ini satu cara kita nak traverse lah, tengok ni. Ini penting ni. Current pula is assigned to the value of current link. Now, current shows to here, betul? So it says now the value of current is the value of current link. Current link is the value is 2800. Okay? So this current here will basically be pointing to this node. So you get this guy here. Okay semua? Alright. Oh, yang panjangnya. Okay. Current holds the value 2800. Okay. Ingat senang lah, current point is this node. Okay. Tapi you kenalah faham kenapa dia value 2800 because of the previous slide tadi. Now, current info yang itu. Current link 1500. Current link info 63. Head link 1500. Head link info. Head link info yang ketiga. Head link 3600. Current link kosong means apa? Null. Ingat ya? Okay. Current link current link info. Current link info. Mana ada info? Dia tak point to nothing. So it doesn't exist. So you can dapat error. Because ini tunjuk kepada null tadi. Dia tak ada lagi current link info. Tak ada. Dia tak ada tunjuk pada any node ada data. Okay, senang. Ini kalau keluar exam mesti boleh jawab ya. Because this one you can really score. Easy question. So this topic make sure you score, you study betul-betul lah. Because very easy to score. Alright. You guys know already how to study smart kan? Now when ada chapter, make sure you focus on the easy chapter, make sure you can score. Obviously, mesti akan ada soalan for each chapter, betul tak? So, the way study smart, katakan you find that subject hard kan, you make sure you control the easy chapter. So, mesti ada soalan daripada situ and then you score full mark there. Okay, that's one of the ways lah ya. Tapi mungkin you ada cara you okay juga. Tapi pastikan cara itu ada result yang bagus lah ya. Okay. Faham semua? Okay. Ayo, semua quiet. Is this one better? This setup macam ni? Guna handphone? Is this setup better using the handphone? I'm using handphone right now. Oh, good ah? Okay. Ayo, now how to build a linked list. Okay. So, kalau boleh nak you digest yang sini lah. Cuma kalau you dah faham, okay, saya proceed yang ni ya. Okay, dia ada dua jenis you nak build linked list ni. Satu you build forward, satu you build backwards. So forward senang lah. You letak satu, you letak dua. You letak dua, you letak tiga. Alright? Kalau you build backwards, you letak satu dulu. And then you letak dua. Then you letak tiga. Okay? So, untuk building a list forward, okay, you kan perlu dua pointer basically. First and last. Because why you see, head always point to the first one. So mula-mula, katakan tak ada 2 dengan 3. Forget about 2 and 3 You ada 1 je kan? Kalau you ada 1 je, Charing Chong, andai kata ada 1 je. Andai katalah ada 1 saja, head dengan last point dekat mana?
Sorry.
Karin, dengar belok. Okay, andai kata node ni ada 1 saja. Jangan tengok 2, 3, ni tak ada. Consider as tak ada, okay? Dia ada 1 saja. So, saya nak tanya you. Untuk building this forward, it requires 2 type of pointer. Head and last, okay? If there is only one node with the value 1, therefore, head and last points to where?
Last points to 1.
Betul. Andai Karin. Okay, Karin. Soalan yang kedua. Andai kata head dengan last tadi, point dekat 1 kan. Lepas tu, I add in nombor 2 ni. Sekarang head dengan last point dekat mana?
Nombor 2.
Mana nombor 2? Tadi saya dah banyak kali saya stress out. Head is always in front. Betul tak? Nama pun kepala. So dia kenalah stay in front. So last akan point dekat mana?
1.
Mana ada carry in? Carry, okay, dengar sini. Head, okay, andai kata satu saja, head dengan last point dekat satu, betul? Dengar betul-betul carry in, ingat. Okay, head always points to the first one. So bila saya masuk and I put in number 2, head points to first, last points to apa, Rebecca? Kepala dia gerak, jawapan dia tak ada, Rebecca. Last points where? Last points kat 2 lah. Cuba fikir logik dia. Head kekal. Last tu, kan you dah letak 1 kan, you nak letak 2. Maka bila you letak 2, last ni kena tunjuk dekat sini. Bila you masuk 3, last akan tunjuk dekat sini, dia akan kekal. Because you build it forward, no? The tail must always be at the end, correct? You think about it. Imagine inside your mind, ataupun you lukis dalam gambar. Kalau you letak 4 dekat sini, then 1, 2, 3, is 3, the tail tunjuk dekat 3. Kalau you ada 4, tail akan tunjuk dekat 4. Dia kena add in the node. Alright? So building this forward, you akan ada 2 pointer. Okay? So of course lah, the node terakhir akan point kepada null. Tapi kalau you tengok, you building this ni backwards. Okay? You only require 1 pointer to maintain the list. Why? You letak nombor 1, lepas tu you letak nombor 2 kan? Nombor 2 ni, do you need the tail? Ni tak perlu. Because this guy points to nothing. So when you want to add in new numbers, you move the head. You add in another number, move the head. You move the head, you move the head, you move the head. Because you keep adding data. Nampak tak? Head ni syarat dia mesti point to the first node kat atas ni. Last node, dia akan point kepada null. So kalau build linked list forward, dia tail dia akan tunjuk dekat belakang ni untuk maintain this no pointer. Untuk maintain linked list ni. Alright? So this is the coding to build a linked list forward. You akan ada new node ni is your node. Dia jenis bentuk dia adalah pointer. Kenapa pointer? Okay, tunggu dulu. Alright? Kita tengok dia just know that for now, to build the node, this fellow here, the node yang ada data dan info ni, saya cakap dia pointer. So build linked list forward, dia kena ada 2 pointer. You kena ada first and last. Ataupun head or tail. Benda tu sama je, nama je berlainan, okay? So first and last. Faham? 6 ni adalah data dia. Anu sini, okay? Anu apa? Kejut Anu. Okay, Anu. Okay. Di antara between these 3 pointers, which one actually creates this node? Ni. Saya tunjuk yang kali ni. Yang mana satu? One, two, or three?
2.
2, betul. Alright? 2. Now, so here, okay, enter data. This is the data, ingat lah, data. Now you say, at first, the first node here points to nothing. Because you haven't created, we haven't asked it to point to anywhere. As long as the number is not negative 99, ni negative 99 ni untuk exit loop ni lah. Okay. Then, new node ni, okay, akan point kepada heap. Ingat tak new ni? New punya command kan point dekat dynamic memory kan? Heap tu kan? Lepas tu, new node is equivalent to new node type. Dalam node type ni ada 2, info dengan link. New node link ni adalah pointer, new node info adalah data. Data here is num. Any questions? You have to ask me if you don't understand, because later on it get more complicated. So this fellow here create the node. This one gives it the value. Because we're creating this guy here. Nampak tak? Mula-mula data yang user masuk tu masuk dekat sini. Mula-mula bila dia dilahirkan, dia tak adalah point dekat mana-mana kena. So kita kasihlah nilai dia null dulu. Dia belum dilahirkan, dia baru dilahirkan. Okay? So mula-mula null lah. Okay? Jika, if there is nothing inside the list, this is soalan where I asked Kevin just now. If there is nothing inside the list, therefore, first pointer points to the new node because there's nothing. Betul? And then, last pointer also point to the new node. Okay? And then, I enter a new number. Then the number C, I put number 5. 5 not equal to negative 1999. Alright, and then you create a new node. That new node, I give the value, I enter here 5. So, new node info num, here the value is 5. New node link, tak diberi apa-apa, because dia baru dilahirkan. Now, is first equal to null anymore or not? Karin? Is first equal to null? Is first the value? No. Because why? First kan tadi dia cakap dia sama dengan new node kan? So it's no longer null. So it goes to the else part. Okay? Then it says, now last points to the previous node just now, the first one that you created. Now, last link. Last link will point to the new node. So, you dah buat satu node sini. So, dia punya link of the previous node tu tadi, because last link akan menunjukkan kepada the new node. So, dia create the link between the first node and the second new node yang you baru buat. Cuba you lukis atas kertas. Patutnya you can see already. Then you cakap, ini soalan saya kepada Karin tadi. Bila you create the new node, then the last you kena pindahkan dia supaya menunjuk kepada node yang baru. You masuk lagi nombor, naik atas, pergi dekat sini lagi. Last link point kepada new node. So you create between the third yang kita baru masuk ni, the third iteration ni, kita sambungkan dia punya link, and then kita move the pointer last tu menunjuk kepada the last new node yang you baru buat. Dan dia akan berhenti bila you letak value negative 1999. So negative 999. Okay. So kalau you tak faham, I want you to ambil paper, ambil pen, draw it out. That one is to aid in your understanding. Tapi kalau you boleh visualize dalam fikir kepala you, then that's fine as well. Alright, so it depends on you lah. Now, building a linked list backward. So instead of having 3 pointer, you only have 2. Because why? Building linked list backward, you only need what? New node and the head. The one that moves is the head. Tadi yang banyak move is the tail. Linked list backward, what moves is the head. Sama macam tadi. Currently first points to nothing. Now, you create a new, first iteration, you create a new node. You put in the value that you entered here, say you enter 1. Then you say new node link is whatever first is pointing to. First points to null. So that means this one, this guy here, this node ni, first iteration ni, it points to null. After that, baru you cakap first points to the new node. Tadi at first points to null, betul tak? Now it points to the first points to the new node. Then you enter a value. You naik balik, create a new node. put in the value, say you enter 2 pula. Now, new node link, the link tadi, is to whatever first is pointing to. First is pointing to the node with the data value 1 just now. Kan? Dapat tak you buat ni? So, now, new node link points to whatever first is pointing to, and then first is going to point to the new node that you created, which is the number 2 tadi. Same, bila naik balik, buat new node 3 pula. New node link akan tunjuk pada whatever first is pointing to, first pointing to new node with the data value 2. Then dekat this line, you cakap, now sekarang ni baru I nak tukar first point kepada new node, which is data 3. So first tu yang bergerak. Okay? Any questions? Alright. Okay. I kasih you 1 minit atau 2 minit, okay? Go through apa yang kita dah belajar. Kalau ada soalan, tolong tanya. Give you 2 minutes ya. I nak pergi toilet sekejap. Okay, then I come back. Okay, then if you got question, ask me ya. Because after this dah susah sikit. Maksud you're going to traverse. So the code is a bit longer as well. Alright? Okay, I give you 2 minutes ya. Okay, any questions?
So far cannot think of one because still digesting.
Still digesting, huh? Okay.
Not
How about the others?
sure what to ask.
Not sure what to ask.
I'm confused, but I don't know what to ask.
Ayo, how come? Okay, kalau you confused kan, first of all ingatlah apa cakap. Tulis dalam paper. Memang you kena draw. Okay? You buat anatomy dia macam ni dulu. In data, link. Data, link. Alright? Lepas tu you imagine ini head pointer, ini current ni katakan tail pointer. Alright? So that's how you do it. Alright? Tapi yeah, I understand lah. If you haven't gone through this lecture, memang can get a bit confusing. Alright? So you have to draw it out actually. Alright? So I give you the concept first so that you understand the concept. Then if anything, then you can always refer back to your notes. Okay? Okay, now kita akan traverse. Traverse means going inside the array, going right inside the linked list. Okay. So when you traverse inside the list, okay, you can search for an item, you can insert an item, or you can delete an item. Alright, so traversing basically you go inside the list to perform search. When you search for a particular number, you want to delete that number, for example, or you want to insert a number that says, okay, this number must be between 11 and 15 because it's the number 13. Okay. Now, to traverse a list, you need a way to move around the list. Okay, head you cannot use because it's always pointing to the beginning of the list. Alright, if you use head, then you tak ada reference pada the beginning of the list. Alright, so head you cannot use to traverse the list. Head must always point to the beginning of the list. So you're going to create a new pointer called current. Okay, and then you say current is pointing to whatever head is pointing. Initial value lah, initial value. Alright. Now you say as long as current is not null, okay. So because if current is null, meaning it's pointing to the last value inside the last node inside the list. So as long it's not pointing to the last node, current is assigned to the value of current pointing to link. Meaning it goes to the next node. Because current is current link mah. Kan? The new value of current is current link. So it means it goes to the next node. So it keeps on going to the next node. Ini you kena lukis atas kertas kalau you masih tak faham. You buat atas kertas, current tunjuk kepada head mula-mula. Lepas tu, anda kata current bukan null, the value of the new current is current link. So it jumps to the next node. It will keep on jumping until it sees the last node, whereby the last node, dia punya link kan points to null, nothing. Then baru dia exit dia punya loop. So you can use current to output the data that is stored inside you punya linked list. You want to retrieve the data inside you punya linked list kan? You can use current. Right? Because you see here, as long as current is not null, I'm going to see out the value of current info. So I keluarkan data tu, kemudian I'm going to move the current pointer to the next node. Then dah pergi atas, I move out the data, I keluarkan data tu. Okay, and then I move to the next node, I keluarkan data tu again. Alright. Okay, now you're going to insert a node inside a linked list. Okay, so struct node type data is of type integer and then link. Alright, so you create 4 pointers, head, pointer P, pointer Q, and new node. Okay, so this one you're inserting a node inside the linked list lah. So you are the 3 pointer ni, head, P, Q belum lagi lepas ni. Alright, now P points to the node with the value of 65. You're going to create a node called 50 that is inserted after P. That means here lah. Okay, so you're going to create the new node first. Okay, P.65, create a new node using statement new node equivalent to new node type. So this is the new node. Okay, new node info, give the data 50. New node link, okay, see ya, you dah create this new node. Sekarang ni you nak masuk dia dekat tengah-tengah ni. Untuk you masuk dekat tengah-tengah ni, this guy ya, dia punya link ni kena sambung dekat sini. Okay, untuk sambung dia dekat sini, you cakap new node link dia is equivalent to whatever P link is pointing to. P link points to here. So bila you cakap new node ni punya link is equivalent to P link, so meaning this link here will point to this guy here. Okay, so you dapat macam ni. So bila you dah dapat macam ni, what's the next task? This guy here, okay, yang ni kena point dekat sini. So nak cakap ini point dekat sini, kita cakap P link is assigned to the value whatever new node is pointing to. So new node points to here, so P link points to here. Tu saya cakap macam wiring sikit. Okay. Now, dia cakap the order in which statement 3 and 4 execute is very important. Okay, why? See ya. If you cakap new node link is equivalent to P link, okay, you akan buat this, you akan buat new node link and P link, so you akan buat connection sini. P link is given the value of new node, so P link is the value of new node. Tetapi kalau you tengok cara ni, kalau dia terbalik, if you cakap P link is pointing to new node, so P link points dekat new node ni. So bila you cakap new node link ni is assigned to value of P link, so P link dah point dekat sini, so new node link dia akan point kepada diri dia juga. So the order is very important. Okay. Now you want to insert a node in the linked list with 2 pointers. So you akan ada P and Q, you nak letak 50 dekat tengah-tengah ni lah. Ini lagi senang lah. Because why? P link, so link ni kita nak sambung dekat sini. Okay. So P link equivalent to new node. So you akan dapat P link masuk dekat new node. Okay. And then you nak sambungkan yang ini kepada yang ni. So new node link is equivalent to whatever Q is pointing to. Masuk kat situ. Lagi senang lah. Using 2 pointers. Okay. So P and Q, kalau you tengok dekat lecture note you ni, later on dia akan panggil dia sebagai current and trail current. Q would be current, P would be trail current. Later on lah you akan tengok dekat lecture note ni. Dia nama je lain tapi dia buat benda yang sama. Okay, macam Rebecca student juga. Dayana Rira pun student juga. Basically dia kena belajar dekat UCT kan. Sama lah, macam tu lah. Alright. So jangan risau sangat dengan naming convention dia. Alright. Kalau you tengok at the end of the day, they do the same thing. Alright. Now deleting a node inside the linked list. Tadi insert, now delete. You guys okay ke so far? Oh, okay ah. Tanzi Shah, you okay Tanzi? You look a bit tired. You're right ah? A bit overwhelmed. Tak apa, faham. It's normal. Okay, Korean model, okay? Korean model. Alright, alright. Okay, now you're gonna delete. Delete ni bit tricky sikit lah. Little bit tricky. Insert is here. Okay? So to delete now. You kena, okay, first of all, of course you need to determine lah mana satu node you nak buang. You need to determine which node you want to throw. Now, you have to point current to the node that you want to delete. Okay? Oh, sorry. Point current to the previous node that you want to delete. Sorry. Point current to the previous node that you want to delete. And then you create a pointer to the node that you want to delete. Now, because you dah delete, katakan you dah delete ni kan, 65 ni kan. 65 ni, you cannot just delete straight away. Kalau you delete straight away, apa akan jadi? Dia tak ada link lagi. Dia bukan link list. Because dia dah pecah. So before you delete, you actually have to reroute dia punya wiring ni. Katakan you nak delete 65 kan. You have to make sure this 45 points to this guy here. Then only you can delete this one. Because baru dia kekal dia punya properties, it is a linked list. Betul tak? Fikir logik dia. Kalau you just straight away buang ni, then rantaian dia putus. Alright? So, for example, you want to delete 34. Okay? So, you're gonna say, you're gonna create a new pointer called Q. Q will be pointing to whatever P-link points to. P-link points to 34. Okay? So, you dah create ni. So, you got 2 pointers. Now, you want to buang 34. Okay? So, this guy here, nampak tak? Ini kan, dia kat sini, you have to reroute it. Supaya dia pergi 76. So, this one, you reroute it like that. So, how do you do that? You're gonna say, the value of P-link is equivalent to, or not equivalent, is assigned to the value of Q-link. Bila you cakap assign to Q-link, so P-link ni will given the value of Q-link. So, dia akan buat this rantai here, or this connection. Only then you can delete Q. Buang dia. Okay? Okay, and then linked list as an ADT, extract data type. So basically, these are basically the operations that you can perform on linked list. Initialize the linked list, print the linked list, destroy the linked list. Ingat ini abstract data type. Alright? So, so this will be the structure of the linked list. You have the node type, info, and the link. This is the UML diagram. So you akan ada, let me see, what is the constructor? Linked list type. Okay, one constructor. Another constructor is linked list type. Oh, this is multiple constructor, and then one destructor. Alright, so you can search inside the list, you can insert at first, you can insert at last node, you can delete the node. So we won't be covering all, we cover a few only. In first, last, and delete node. Okay, unordered linked list is basically a derivation of a linked list. Data list, unordered lah basically. Alright. So in order for you to search in a linked list, if you found the item that you want to search, you will return a value true. Otherwise, you will return a value false. Step 1, compare the search item with the current node in the list. If it's the same, stop the search. Else, you move to the next node. Okay? So you keep on repeating this process until the item is found, or you have reached at the end of the node and you still cannot find it lah. Okay, either you jumpa ataupun you tak jumpa. Now, property you akan dapat untuk unordered linked list ni, search function ni, return type adalah boolean. That means true or false. Okay, parameter yang they accept is the search item, the items that you want to find lah. Okay, then you create a pointer, points to the node or current. Boolean function, which is denoted by the variable found here, is set to false at the beginning. When you find it, then only you set it to true. Belum jumpa, ni initialization dahulu. Right, ingat program you mesti ada start state kan. Ini initialization ataupun start state dia. So you imagine kalau you ada, this is the list lah. You imagine dalam kepala you, this is the list. Head ataupun first always points to the first side the list, betul? Because you need a reference to the first node. Head or first is the same thing. Nama je lain. Ingatlah saya cakap, banyak kali saya ulang ini. Okay. Now, while current is not null, that means you haven't reached the end of the list and you haven't found the item. If current info, so current will be pointing to the node, is the same as the search item that you want to find, you set the found boolean function found to true. Else, you're going to move to the node. You move to the next node by saying current is assigned to the value of current link. So katakan you nak cari 65 kan, 45 points dekat current. Sama tak? Tak sama. So bila you buat tak sama, you pergi dekat else, current is equivalent to current link. Current is equivalent to current link. Current link points to this guy. So current move here. Okay? Karen, okay Karen? Okay, ah? Nawang, are you alright? Yeah? Right. Okay. Now we're gonna look at how to insert at the head of an unordered list. So new item is the data lah. Okay? You create a new node. So you create a pointer. Now you create a new node. The data is a new item. New node link is pointing to whatever first is pointing to. So first points to the head of the list, the first one. So new node link, if your link ni, you point to the head. So you letak dia dekat depan. So apa yang bergerak? First ni, dia kena bergerak, dia kena point to this new node. Betul tak? Because it is at the head of the list. So first is pointing to whatever new node. First is pointing to the new node. New node points here. So this guy here allows you to do the blue line here. Nampak tak? This single statement here. Ini soalan yang saya tanya Karin mula-mula tadi. Karin, you must be master at this area already. Because I answer the question specifically for you. Betul tak? See? Ini basically the blue line here. Now, why you have this count plus plus? This count plus plus, because you add in new items inside the list, right? That means the size of the list will also increase. So the count here is actually for the size of the list. Okay? Now, let's check up if last is equivalent. If the last is equivalent to
So you okay, sir?
Sir?
How the bad outlet of audio?
no, sorry for the distraction. My apologies. Okay. Okay. So here, if last is equivalent to null, meaning that the list is empty. All right. So basically, if it's empty, then last will also point to the new node lah. Because you letak benda kan. So first and last points to the new node. All right. Now, so this one, if you keep on adding it at the front, what happens if you want to add it in the middle? So middle is like this. 28 here, you want to put the middle here. Okay. So, P ni, all right, points to the whatever head is pointing to. So it points to the first node. Q, okay, is going to be pointed at 15. Okay. So P is pointing to here. Q, dia akan cakap points to here. So bila Q points to here, you can say the value of P, okay, is basically assigned to the value of Q link. So Q link points to here. Betul tak? So P akan bergerak dekat sini. 30. Alright? Now, if P is here, Q is here, you want to insert this new node here. So you need to say, first of all, you need to create the link. This new node here is going to be pointing to here. This fellow here, this node here. So how would you do that? You're going to say new node link, the value of new node link is pointing to whatever P is pointing to. So you get this guy here. Okay? Then, you akan cakap, okay, you want to create this guy here, instead of pointing to 30, you akan cakap yang ini point to this guy here. So how do you do that? So you type Q link is assigned to the value of whatever P is pointing to. Because Q points to here, right? So Q link, oh sorry, sorry, my mistake. So you want to create a link here, this guy here points to this guy here, sorry, my mistake, yeah. So Q link is basically going to pointing to the new node. So you buat this sambungan here. Okay? Alright. Okay. So now you're going to look at inserting at the tail of an unordered linked list. So tail ni dekat sini lah, dia akan masuk dekat sini. So first ni kekal. First points to the first node. So you want to add in dekat dia punya tail. So last points to the last node. Okay. So for now, okay, kita create node tu dulu. So new node, you create it, you put in the dynamic memory. New item, you put inside the data, which is whatever data lah. Okay, you put here. New node link currently points to nothing, mula-mula. Okay. Now, dia ada dua condition. If first points to null, meaning list tu nothing, tak ada apa-apa dalam tu. Therefore, first akan point kepada new node. Last pun akan point kepada new node. And then you increment the size of the list. Itu if there is nothing inside the list. But what if there is something like this? So if there is something, then when you create a new node, this last here, okay, needs to be pointed to the new node. And new node ni, dia punya link points to null. Okay, so how would you create it? You cakap, okay, last link, you nak create yang ni supaya dia sambung dekat sini, is equivalent to whatever new node is pointing to. So this statement ni creates this line here. Nampak tak? Dia sambungkan. Okay. So, new node link ni memang dah null. Okay, it points to the end. So, never mind. And then, bila you dah ada ni, last is here. So, because you add in this new node here, therefore, last should be this one, right? So, last is going to be assigned to whatever value new node is pointing to. And then, you increase the size of the list count. Okay? Any questions? All right. Now you're going to delete an item in an unordered linked list. Okay. these are the different cases you have to consider lah. Alright, the list is empty, the load list is non-empty, and the need to and the node to be deleted is the first node. So the first node basically benda yang you nak delete tu you jumpa dulu. You faham tak? It's the first thing that you find, the value of the first node that you find, that is the first thing that you want to delete. Okay. So benda you nak delete sesuatu kan? You nak delete, you kena search, betul tak? So bila you search, benda yang pertama you jumpa tu lah benda yang you nak delete. So this case 2. Case 3, I don't want to go to A and to B, so I come back later. Case 3 adalah the node that you want to be deleted is not the first node. Meaning you have to traverse inside the list to get the value. Okay? And then case keempat, the node to be deleted tak ada. So you search inside the list, memang tak ada node tu. So dia ada 4 case. So dalam case 2 ni, ada 2 circumstances lagi. The list has only 1 node. Okay, so kalau you buang habislah node, list tu. Tapi it can happen, right? You only have 1 node. So you delete it, habislah. Alright? Or, the list has more than 1 node. Bila you ada more than 1 node ni, ada problem sikit because you have to reroute, you have to do the rewiring balik. Alright? Same with nodes to be deleted. The node to be deleted is not the last node. So you have to do rewiring balik because dia bukan last. Or the node to be deleted is the last node. Same also, you actually have to rewire balik. Okay? Now, this is the pseudocode. If the list is empty list tak ada apa nak delete. So you cannot delete lah. Alright? Nothing to be deleted. Else, if the first node in the node, yang ni, if the first node is the node that, if the first node is the node with the given info, adjust the head pointer that is first and deallocate the memory. So benda yang you nak jumpa, yang you jumpa tu, benda pertama you jumpa tu ada benda yang you nak delete tu, then you just adjust the head pointer, then you delete. Else, you have to go throughout the list. Alright? If you find the node, delete it and adjust the value of the last if necessary and the count. So, ini you delete the node, you nak perform the operation delete node. Alright? This is the item that you want to delete. Okay? So, you're going to use 2 types of pointer, current and trail current. Or pointer P or Q or head or first, doesn't matter. Okay guys, I want you to go through this, I give you 5 minutes, you go through this alright, then I'm going to explain it, okay? So you pun ada have some idea, then when I explain then you have a better understanding, okay? So I give you 5 minutes, go through this pseudocode, yeah? Okay, everyone. Okay, have you gone through? Okay. If you've gone through, okay. The operation here is delete node. Kalau you tengok dekat UML ni, it'll be this guy here. Okay. Delete node, void. Sama lah dalam UML diagram tadi. Okay. 2 pointers, current and trail. Boolean function if you find it. Now, this one, you have to relate it with the 4 case scenario here. First one, list is empty. So, if the first pointer points to nothing, alright, first pointer always points to the head of the list. If it points to nothing, meaning there's nothing inside the list. So, you're going to tell the user cannot delete from an empty list. Faham? Okay, good. Faham satu. Else, maknanya first tidak point to null lah. Dia cakap is if first info is the same as delete item. Meaning the first info, the first thing that you find inside the list is the same as the item that you want to delete. Case 2. Node is done empty and the node to be deleted is the first node. Nampak dekat sini. Is first info, meaning first pointer. Okay. Data tu kan dalam tu adalah sama. So that means the first node lah. Sama dengan data dengan delete item dengan yang you nak delete tu. Now, ini dua pointer yang you baru buat. Current is going to point to whatever first is pointing to. Okay? Because this current, you perasan so current will be pointing to whatever first is pointing to. That means the first node tadi. Bila you delete the first node, now, Rebecca, Karen, bila you delete the first node, ingat tak? First node must always point to the first node inside the list. Sekarang ni, you nak buang benda yang pertama tu. Nampak tak? Because you want to throw away the first node, therefore, the first you have to move it to the second node. Because you delete the first already, right? Imagine ada pemenang 1, 2, 3. You keluarkan pemenang yang pertama tu. Okay? So bila you keluarkan pemenang pertama tu, okay, first tu pemenang kedua jadi first lah kan? Because you katakan pemenang pertama disqualified. So pemenang kedua akan automatically jadi first, betul tak? Sama lah konsep dia. So first ni you kena move kepada second node. How you move it? First is assigned to the value of first link. Because first link points to the second node. Betul? That's why I suruh you baca dulu tadi 5 minit. Kenapa count minus? Kerana bila you akan delete node tu. So list tu kenalah kecil. So count tu tolak. Because list dah kekurangan 1 okay. Now, ini if first equals to null, last equals to null, apa maksud dia? That means first equivalent to null. If first equals to null, that means last equals to null juga. So basically dia cakap list tu dah tinggal the list has only 1 node je. Alright? Okay, now ini if benda yang pertama you nak delete tu adalah benda yang you jumpa. But what if the item is not the first thing that you want to delete? Okay. So it's not the first thing that you want to delete. Therefore, therefore, Boolean function, now here, you're going to delete it as false first. Okay. Now, trail current ni dia trailing this current. Is going to be pointing to whatever first is pointing to. Ini remember, ini else ya. So maknanya, kalau you tengok dekat sini, first ni, current ni, okay, current basically akan point kepada first link. So dia akan point kepada second node. Trail current akan point kepada the first node because trail current is assigned to the value of whatever first pointer points to. First pointer points to the first node inside the list. Ini dia berbeza sikit. Dia introduce konsep trail current. Nama dia trail current, maknanya dia akan mengikut current. So if current pergi ke 3, trail current akan pergi ke 2. P and Q. Remember just now we do the P and Q? Same concept. Nama je lain, tapi konsep dia sama. Okay? Ini dangerous sikit. Ini agak susah nak faham. Okay. Never mind. Tulis dulu dalam kertas. Found false dulu. Trail current ni pula, dia point kepada node yang pertama. First node. Current ni pula, okay, current ni you bergerak. Dia akan move kepada second node. Okay. Now, ingat ya, case ketiga ni, the node to be deleted is not the first node, but somewhere inside the list. Okay. Ini 2 tadi, ini 2A. Ini 2, okay, alright. So, ini case 3, okay. Kita kat sini tadi, current current points to the second node. Now, as long as current is not null, meaning haven't reached at the end of the node, and you haven't found the item yet, and if current info is not the same as the item that you want to delete, you are going to keep on moving. Trail current is going to point to whatever current is pointing to, and current will go to the next node. Okay. It will keep on repeating, okay, until here. Okay, so you see, ini syarat ni, as long as current is not null and you haven't found the item. But if current info adalah sama dengan delete item, that means dia dah jumpa item tu, dia akan set found kepada true. Apa tak dekat sini? If you haven't found the item, you're going to keep on moving. Alright? It will keep on moving, okay, until you find the item. Okay, so found dah set dekat true, okay, and then you reach, okay, ataupun you tak find the item, meaning the basically the boolean function here found is false lah. Okay, that means you never found the item. Alright. Now, if you have found the item already, okay, trail current, now, ini you jumpa, you belum delete lagi, you jumpa. Ni bila you dah, you see, while you masuk dalam view, you cari. Kalau you tak cari, tak jumpa, you keep on going until dia reach null. Okay, bila dia reach null, dia akan exit lah while loop ni. Either dia exit the while loop, tak jumpa, ataupun dia jumpa and set this to true. If dia set this to true, dia masuk dekat sini. Trail current link is the same, is going to be assigned to whatever current link is pointing to. Ini you dah jumpa benda yang you nak delete tu, we found. Okay. Now, current link ni, okay, trail current link is pointing to whatever current link is pointing to. So, this guy is the previous one to whatever current is pointing to. Betul tak? So, bila you buat trail current link is sama dengan current link, you basically trying to reconnect the wire daripada node yang before benda yang you nak buang kepada node yang seterusnya. So, the previous node that you want, before the one that you want to throw, this is the one that you want to throw. Current points to whatever you want to throw. Okay? So, trail current link is assigned to current link, meaning the next node. So, you akan buat the wiring, then you minus the count. Because you already going to delete. You belum delete lagi, you nak delete. So the list size you reduce by 1. You reduce the size by 1. Now, if last is equivalent to current, that means the thing that you want to throw is basically the last node. Then you have to tell, because here if it means if is the last node, if is the last node, then you're going to say last will point to whatever trail current is pointing to. Trail current is before current. So you have to move the last. First points to the first node, last points to the last node. So if you nak delete yang last node tu, tail dia ataupun last tu, you kena move to the previous one. Betul tak? You fikir? You kena move dia dulu sebelum you delete. Kalau tak, nanti last tu hilang. So last tu will go point to whatever trail current is pointing to. Only then you delete current. Meaning, you buang. Tapi tengok you have to be careful with this sentence. If only applies last current. Okay, if last is sama dengan whatever current is pointing to, then you do this. Else, whatever the case is, this one is not if else. Jangan salah This is not if else. If this is tak dipenuhi, this will be executed. If this dipenuhi, this will also be executed. Be careful with that. You kena faham. At the end of the day, delete current, if found, delete current tetap akan berlaku. Selalu student confused. Dia ingat ini if else. Ataupun if ini betul, then dia ingat this delete is part of if. No. If this is correct, then you do this. Whatever it is, whether this is correct or not, you tetap akan buat delete current. You kena faham that one. Ini yang salah Ramai yang salah ni. Because there is no kurungan je. Kalau ada kurungan sini, kurungan dekat belakang ni satu lagi, then it's a different thing. But there is no kurungan, right? So if this is correct, this will be executed. This also will also be executed. If this is wrong, this will not be executed, but this will also still be executed. Yang ni yang banyak confuse ni. Saya tengok ramai dah confuse. That's why I ask to read first je tau. Okay, ada soalan ke tidak? Benar Rika, you okay benar Rika? I dah tengok muka you pun I risau. Okay tak benar Rika?
Masih tengah digest. Masih tengah digest.
Ayo, masih tengah. Ayo, okay, tak apalah. Okay. Cuba tengok dulu kalau saya boleh jawab kalau ada soalan. I think this one semua okay. Ini sangat simple. Ini basically case ni benda yang pertama yang you nak jumpa tu adalah benda you nak buang. Okay. Tapi dia ada dua case. Satu node ataupun more than one node. So ini dia cakap if is one node. Okay. Tapi at the end of the day dia tetap pakai sorry. Okay. So ini if is one node. Okay. Now, ini you nak search dalam node yang lain. So, bila dia search ni, ini dia search saja. Dia belum buang. Dia buang actually dekat bawah ni. Delete current is where dia buang. Ingat tu. Dia tak buang dekat sini tau. Ini dia search je. Kalau jumpa atau tidak. Dia ada dua condition dia keluar ni. Kalau you jumpa ataupun you tak jumpa dalam ni. Itu je. The delete is this part. Lepas tu you be careful with these two things here. This will, kalau you dah masuk within this open and curly braces, because you already found, it will definitely be definitely be deleted. Because dia ada condition yang ni, if last is equivalent to current, you have to move the trail current. Because trail current tu dia kena move, dia kena point to the last of the node. So kalau yang last tu you buang, then trail current tu, you kena move to the previous node. Kalau tak, dengan dia hilang. Okay, faham? Ataupun 50% faham. I know, memang code ni panjang actually. Dia, yang buat dia confusing tu dia macam, it's like a thread, you know, that keeps on pushing with other threads. Betul tak? So it's all jumbled up inside the mind. Rebecca, okay not Rebecca? Not okay. Any questions ke? No question because still understanding.
Something like that. No question.
No question for now. Okay.
Still
Yeah.
suggesting.
Okay, tak apalah. It's okay lah. Get 50% menjadi. So I provide you the guideline first lah. Huh? So what you do is you mesh this code here. Dia ada bagi tahu you labeling kan. Case 1, 2, you delete dengan yang ni. Cuma dia punya thread dia dekat sini, yang buat satu student confused. Sini dia, bahagian ni tak buang. Ingat saya cakap. It's not deleting it. It's just finding it. Finding the items. Is it the item that you want to delete or not? Delete is here. This line here. So dia akan berlaku 1 dengan 2 kali ni aja. Dia 2 je. Itu saya kasih guideline lah supaya you tak salah faham nanti. Tapi kalau you belajar seorang-seorang you salah faham. Ingat yang ni delete tak. Ini search. Dekat sini baru dia delete. Lepas tu yang ni lah. This one. Whatever there's between this open and curly braces, delete will happen. Regardless this one dipenuhi atau tidak. Because this is if, not if else. So student always confused. Dia ingat ini if, correct, do this. Else do this. No, wrong. This is definitely going to happen. Okay? Okay, I move on because we got a few more minutes. Okay, so we're gonna look at unordered linked list. Unordered linked list is a type of linked list. Okay, so if you want to search in ordered list, ordered list ni macam 1, 2, 3, 4, 5, 6 ada order lah. Alright. So compare the item that you want to search inside the node inside the list. If the info of the current node is greater or equal to the search item, stop the search. Tengok yang ni. If it's greater or equal to the search item, stop the search. You nampak kat sini? Dia tak sama. If it's bigger or the same. Yang tadi tu dia kena sama. Comparable. This one if it's bigger or the same. Different thing lah. Nampak tak? Dia sudah 2 benda yang berbeza kat sini. So dia dah highlight dalam blue untuk you. So saya nak make your understanding easier, saya point it out inside the code yang mana satu. This greater or equal to is this value here. Nampak tak ni? If it's the same, set to true. Because dia cakap, if the item is greater or equal to the search item, stop the search. Nothing to search anymore. Okay? Else, make the next node the current node. So, if it's greater, stop. Stop, you send, the boolean font is false. So, if it's greater than, you stop because you're going to set the font as true already. Alright? If it doesn't fulfill this condition, then only you move the current pointer there. Make the next node the current node. So that means current is going to be assigned to the value of current link. Current link will go to the next node. Okay? Then you repeat step 1 until an item in the list is greater than or equal to the search item is found, or there's no more there's no more nodes to be searched inside the list. Okay? So here is basically the code. Alright? At first, current is going to be pointing to whatever first is pointing to. As long as it's not the end of the list and you haven't found the item, if the item is the same or bigger, okay, you're going to set it to true. Follow this code here. Okay? Else, move to the next node. Okay, this one here. This code here. So you're going to keep on repeating until you find it. If you find it, current info is equivalent to the search item that you want to find. Okay? Otherwise, it means that the item is never inside the list. Number 2 here. Okay? So you use this one as a guide to understand your code. So another way to think about it, bila you tengok current is equivalent to current link, ini usually traversing to the next node. You pergi to the next node. Okay, next is inserting an item into the list. You're going to use two pointer, current and trail current. Okay, the case that you have to, the different scenario you have to take into account is the list is empty, nothing inside. Alright, so if you add in item, then they will become the new state lah. 2, the new item is smaller than the smallest item inside the list. So you have a list order is nombor 2, 3, 4, 5, 6, 7. You nak add in nombor 1. So 1 tu pergi mana? Pergi mana? Dalam list you ada 2, 3, 4, 5, 6, 7. So you nak letak nombor 1. 1 pergi dekat mana? Mana Rika? Tak dengar apa Rika?
Beginning of the list.
Beginning of the list lah. Kan, ni 2, 3, 4, 5, 6, 7. So you nak letak 1, dia kena letak kat depan. The beginning of the list. Betul, thank you. So bila you nak letak benda tu at the beginning of the list, first points tu nombor 2, betul tak? So bila you nak letak 1, maka you kena adjust first punya kedudukan. First tak boleh lah tunjuk kat 2 lagi. Dia kena tunjuk dekat 1. Tak payah fikir lah, senang je. 1, 2, 3, 4, 5, 6, 7. Tak mana awak ni. Okay, so kita letak 1 kan. Tak payahlah fikir. 1 nak letak dekat 2. Okay, so kalau first pointing to the first node, so if first point to second, now first has to point to first lah, nombor 1. Okay, lepas tu you kena increase the size of the list, tambah 1. Because you add in something new lah. If you add in, you tambah 1. If you buang benda, you delete 1. Mudah je. Okay. Okay, yang ni ada complicated sikit. This one you have to be careful. The item to be inserted is somewhere inside the list. Usually this one is the problematic one lah. Add in dekat depan belakang senang. Add in ke tengah tu ada problem sikit. See? Because if the new item is larger than all item inside the list, okay. So, bila item tu larger than semua item at the list, then the new item you insert dekat end of the list. Okay. Lepas tu, trail current. So, you letak dekat end of the list. So, trail current will be pointing to the previous node before the end. So, you put it after trail current. So, current is pointing to null. Because current points to the item that you want to add. Alright, so current link null. Okay, how is incremented by 1. So, you tengok dekat sini. Current is equivalent to, if current is equivalent to null, then last is the new node. So, dia nak check lah. Okay, dia nak check is it the last node. If it's the last node, then tail has to be pointing towards it. Alright. Sorry, here is actually the value of, they check if the value of the current is null. So, it should be, sorry, just now saya cakap, apa tu, the value of current is null. It should be if the value of current is equivalent to null, this one here, then last pointer would point to the new node because it's the end of the list. Alright, case 3B is if the new item is to be inserted is somewhere inside the middle of the list, that is going to be between tail current and current. Ini yang you kena adjust the link. Because you add in tengah-tengah. 1, 2, 4, 5. You letak 3, you letak nombor 3. That means 2 sekarang kena tunjuk kepada 3. Dan 3 link kena tunjuk kepada 4. Cuba you fikir. You ada 1, 2, 4, 5 kan? Bila you nak letak 3. Link 1 tunjuk kepada 2. 2 sekarang kena tunjuk kepada 3. Node 3 yang baru tu akan kena tunjuk kepada 4 pula. Dia macam ni rupa dia. Dia nak add in tengah-tengah tu, it will look something like ni. Will not join. Sorry. This one. Nampak tak? You nak masuk tengah-tengah ni kan? So this one you have to reroute it, tunjuk dekat sini. Yang ni you kena tunjuk dekat sini. Okay? Okay. So sama delete node, delete item. Sorry. Where was I? Okay, here. So you create here case 1. If the item is list is empty, then the first node or the first pointer will point to the new node, last pointer also point to the new node. Okay. Tetapi if first is not equivalent to null, current is going to be pointing to whatever first is pointing to. So they're pointing the head of the node. Found is set to false. Alright. Now they're fine. As long as current is not null and you haven't found the item, current info you check, is it bigger or smaller than the new item? If it's bigger or smaller than the, if it's bigger or equivalent to the new item, then set found to true. Else you're gonna move current. Okay. Now, case 2. If the new item is at the beginning of the list, you adjust first. So if current is pointing to the first, alright, then new node link will be pointing to whatever first is pointing to. Okay, so new node ni akan point to the previous first, then the first pointer ni is going to be pointed to the new node. Terus ni akan jadi the head of the new node. Then you increment the size by 1. Else, if it's not the first item, then jatuh pada case 3. 3 ada 2 senario, 3A dengan 3B. The item is to be inserted somewhere inside the list. Either is the last item or somewhere inside the middle of the list. Case 3. Trail current equivalent, trail current link, okay, is going to be assigned to the new node. Okay, so trail current link is going to be assigned to the new node, and then new node link is going to be pointing to the current, whatever current is pointing to. Okay, so dia ada 3 case, 3A and 3B. Now, trail current link is going to be pointing at the new node. Okay, so trail current is before current. Trail current link now pointing to the new node. And new node link ni, okay, the new node link is going to be pointing to whatever current is pointing to. Okay, if current is equivalent to null, okay, it points to nothing, then last is the new node. It's going to be pointing, last is going to be pointing to the new node. Alright? Because it's at the end. So dia 2. Dia akan tetap point kepada new node ni. Trail current, okay, you point kepada new node. Alright? And then new node ni, link dia akan point to whatever current is pointing to. Alright? So kalau we tengok dekat sini, where is the P and Q just now? Ni. Katakan ini trail current kan, dia point kepada new node. Alright? And new node link will be pointing to whatever current is pointing to. New node link is pointing to whatever current is pointing to. So, you tengok dekat sini, new node link is pointing to whatever current is pointing to. Sama macam gambar tadi. Alright? Ini, if current is null. If current is null, then only last pointer you move to the new node. Okay? And then, of course, you increase the size. Alright. Now, this one is insert at the head of the ordered linked list. You guna the function insert lah. Alright. Insert at the tail pun sama, you can guna function insert. Right, inside the insert last. This one is insert first, you guna normal function insert. Now, deletion in an ordered linked list. Sama case dia, if list is empty, the first item is the item that you're going to be deleted. Tadi add increment kan, ini delete. The item to be deleted is somewhere inside the list. Alright. So current points to the node containing the item to be deleted, and trail current points to the node just before the node pointed by current. Case 4, list to empty, nothing to be deleted. Case 1, if first points to nothing, nothing to be deleted. Alright. Then current is pointing to whatever first is pointing to. That means points to the head of the linked list. Found is set to false. Now, as long as current haven't reached the end of the list and you haven't found the item, you're going to see if current info bigger or the same as the item to be deleted. If found, set to true. Else, you're gonna keep on traversing the list. If current is null, meaning you cari dekat dalam list tu, tak jumpa, then the item to be deleted is not inside the list. Right? If you want to delete item, you have to first search for the item, then only you can delete. So this case is, you cari dalam list tu, you tak jumpa. So nothing to be deleted. Case pertama adalah nothing inside the list, so nothing can be deleted. Okay? Next, if current info adalah sama dengan delete item, okay, then you check if the first and current the same or not. Okay, if the value of first and current is the same, okay, first and current is same value, first is going to be moved to the next node because first is assigned to the value of first link. Alright. Now, I'm going to skip this part first, then you're going to delete it. Okay. However, something else might happen if first is equivalent to null. Okay. Then last must also equivalent is going to be assigned to the value null. Okay. Now, if first is not current, the value of first is not the same as current, trail current link is going to be assigned to the value of current link. So trail current link is going to be assigned to current link. Alright? So what does this mean? Trail current, dia punya link is assigned to whatever current link is pointing to. Trail current is behind current, so that means it goes to the next one, the next node. Alright? If current is equivalent to, okay, skip this part first. So, if first is not the same as current, alright, then trail current link is going to be assigned to whatever current link is pointing to. So, dia macam skip like that. Alright, then you delete current. So, this is because you delete something, they delete current ni, so you have to do the connection, the sambungan. If you look at this example, delete. Where is delete? So this is insert. So macam you nak delete, katakan Q ni current kan. So bila you cakap P trail current link is equivalent to ini current link, so you establish this sambungan dia. Nampak tak? You tengok code trail current dengan current tadi. Trail current link, katakan P is trail current, Q is current. Trail current link is assigned to the value of current link. Dia akan buat this sambungan dia. Then baru dia dapat delete. Nampak tak? You see the code just now? Trail current link is assigned to the value of current link. Then only you delete current. Okay, yang ini pula, if current is basically the same as last, so because you delete current, then last ni kena move because you're going to delete the current, right? So last is going to be pointing to trail current. You tak boleh biar dia point to current because current we delete it, then you can hilang pointer ni. So if current equivalent to last, then last ni you have to move this supaya dia jangan point dekat current, dia tak sama dengan current lagi supaya dia point sama dengan trail. So the trail will become the new last. Okay. Case 4 senang lah. Item tu tak jumpa. That's why dia cakap see out saja. No function, no nothing. Just see out. Okay. Okay. Alright. Next we go to doubly linked list. Doubly linked list dia ada konsep of successor dengan predecessor lah. So if this node dia ada pointer, successor point to the previous node. Successor points to the next node and predecessor points to the previous node. Alright. So this is basically a doubly linked list allows you to traverse from the head or the starting of the first node or from the last node. Alright. These are basically all the operations that you can perform on the doubly linked list. So for more information, you can refer to your textbook. Yeah. Circular linked list is a little bit different. This is an empty circular linked list. This is a circular linked list with one node. This is a circular linked list with more than one node. Now, if first, okay, first bila you ada circular linked list, first pointer ni akan point pada last node inside the list. So by doing that, okay, you can access both the first and the last node using the first pointer. Nampak tak? Because first ni point dekat last node. Kalau you nak refer to the first node, then first link pergi kepada first node. First points to the last node. So that's why you letak first pointer kepada the last node. Okay. So deletion or insertion in for the first node, basically you akan guna header node dengan trailer node lah. Alright. Now, a node placed at the beginning of the list contains a smaller value than the smallest value in the data set. A trading trailer node ataupun macam current trailer lah. Macam current trail. A node placed at the end of the list containing a value larger than the largest value in the data set. So basically, smaller value, biggest value. Alright. So in order to traverse it, you use header node dengan trailer node. Alright. So smaller node, you can smaller node nanti you can letak dekat the smallest value in the list. Big largest value you can letak dekat the hujung sekali. Alright. So smallest value beginning, largest value at the end. Alright. Implementation wise dia sama macam yang ni lah. Same. Just that the design of the linked list is different. Alright. So you already learn how to traverse, how to search, insert and delete, how to build a forward linked list and backward linked list. Okay. And then we go look at how to insert and delete in ordered linked list. Doubly linked list you have to you have to search inside you punya textbooks ya. Dalam ordered linked list tadi kita cover insert and delete. Alright, so here. Alright, and then we look at linked list with header and trailer. Header and trailer is for circular linked list. This one here. Alright. Okay, any questions?
Sir.
Yes.
Good afternoon, sir. May I know what is the STL container list?
Which slide?
Yeah, 69. STL sequence container list.
Oh. STL sequence container list. Alright, so this is the container. This is the template. So this is the template. You akan data, you ada integer first and last. Alright, so these are the operations that you can perform in the ADT list. STL is standard template library.
Standard. So the UML class diagram and the container are the same thing.
UML diagram is UML diagram. Here basically, okay. Alright, so you tengok ni kan, STR template ni kan. You see the search function, right? This is the template. This search you can basically get from this guy here, from the UML. So basically what it's trying to say here in the container here for linked list, these are the data. You are the pointer, you can add the data. Okay, these are the operations that you can perform. Okay, for linked list, which is to search, insert, initialize string, get the length of the list. Alright, so did we cover all the implementation? Tak ada. We only covered search, insert, and delete. Okay, but you can say that for linked list, you can have length, you can have print as a function implementation. Okay. Okay ke? Okay, any other questions?
Sir, can I ask about the assignment? When will it be out?
Okay, before I ask about assignment, quiz first. Quiz is next week. Quiz adalah next week. Chapter ada tulis dalam you punya schedule. Inside the quiz, the question is 10 questions. Semua orang akan dapat different set. Okay, yang penting here, be careful lah. After you answer one question, you cannot go back. Why is it designed like that? Because kita tak nak student meniru. If you can go back, you can, create a WhatsApp group and put the question there and ask your friend. Okay? So that's the whole reason lah. So if you cannot go back, meaning you have to answer and then you cannot post, no time to post the question in the group. Because you already answer mah. Okay? So, jangan, okay, I tak nak you pergi quiz, nanti ingat you boleh ask your friend to help you. Semua orang akan dapat soalan yang berbeza. Okay? Alright, so you have to study lah, basically. Okay, yes, can ask a question about the assignment. Any questions regarding your quiz? Your quiz is during your lab time. It is 15 minit, 10 soalan. Okay? Okay, any questions regarding the quiz dulu? Okay, kalau tak ada question regarding the quiz, kita proceed dengan question regarding the assignment. Okay, yes. Siapa nak tanya soalan tadi?
When will the assignment question be released?
I already released what?
Ada ha?
Ada, kat Elite. Ada tak?
Wait, I go check a while.
Ada kan? Yang lain dah access tak? I released it last week. Tolong check. Tak ada. You group what?
No, group 5.
Ay, how come? Wait, ada ke? Ay, that's so weird. Wait, let me just double check balik. Alamak. Okay, never mind lah. I lupa nak upload lah. Your group I lupa nak upload. Never mind, I will extend the due date lah. Don't worry about it. Okay? Thanks for reminding me. My God. Okay, alright. Okay, I will extend your due date, yeah? So don't worry about that one. Okay, I'll upload it after this. Okay, all right. Thanks for reminding me, Rebecca. Any other question?
Sir, if the quiz is objective only.
Or MCQ objective.
Okay. Thank you, sir.
Okay, welcome. All right, thank you, everyone. Okay, after this, I upload the question, yeah? All right, okay, thank you, bye.
Thank you, sir.
Yes, sir.